we have been developing a web application for a travel agency. To do so, we created transaction objects, applied the Fiori pattern that creates objects as web panels, procedures, etc., and we would continue to work. In this way, developing objects until completing the web development. In our case, we've prototyped in a local server that accessed a HANA database through HANA Cloud Platform. However, when we deploy our application, the programs built by GeneXus in Java will be saved in a server that can be accessed from the web. Therefore, the end user, with the browser and the URL of some of the app's pages, will be able to run the corresponding object built by GeneXus in Java. If necessary, it'll make requests to the database and return the data to the browser to have it build the page with the retrieved data and display it to the user on the device screen. How do we obtain an application similar to the web application, but native for Android and/or iOS devices? We will do so by developing some specific GeneXus objects for smart devices that will be compiled from a main object. GeneXus will compile that main object in Java for Android if the application will be built for that platform, and in Swift for iOS if necessary. In addition, for these native apps to be able to access the data stored in the centralized database, one part of the web app, Java, is exposed as REST services. Therefore, when the Android or iOS app needs data from the database, it'll have to consume the corresponding REST services. The developer doesn't need to worry about this because it's hidden inside the logic of the GeneXus objects for smart devices. We will see this with an example. To review what we have done, in the web application, we have the app home object, the Launchpad, which is a sort of menu. From this object, we invoke various lists, the Fiori list report of countries and attractions. We had also explicitly added the invocation to a transaction called customer. Here, we leave it aside. We want something similar but for smart devices. To do so, first, we will apply the equivalent pattern to the Fiori list report to the transactions we're interested in. We open the Patterns section of the country transaction, Work with for smart devices pattern. There are great differences with the same pattern for the web. The Fiori list report showed a tree with nodes to state what GeneXus should implement later through these objects. At runtime, these objects were displayed as two screens, that of the list itself, and that with information of the selected country. This screen has a General tab, and since each country has associated attractions, another attraction tab with these attractions is displayed in a grid. If we collapse the tree adequately, we can see where each one of these screens is configured. Here is that of the list, and here is that of detailed information about a country with their two tabs. If we now open the equivalent pattern for smart devices, we can see more clearly the two screens that will be generated. One for the countries list, and another one with detailed information of a country, with their two tabs displayed as sections. The great difference is that here these nodes will correspond directly to the objects generated and will not be declared by the developer to have them later implemented by GeneXus. Instead, they will be implemented directly. So if we click on the list node, here is its layout, which has been initialized and has a grid that will show the value of the country name attribute of each country to be loaded from the database. In addition, we can see that sections such as rules, events, etc. are enabled to define rules, events, and other aspects of this object. That is to say, the sections that allow for its implementation are displayed. In addition, if we open the detail, we see that the screen object only contains a control called All Sections Content. All the sections contained in this detail will be loaded in this control. Here, there are two. One that shows the country's general information. Here we see the attributes country ID and country name. And the other one that shows the country's attractions in a grid. The attributes attraction photo and attraction name have been placed here. It'll be clearer when we run it. Let's select the checkbox to apply this pattern. Before saving, let's take a look at the generators of programs that we have defined. So far, it's only one, for Web Java. Now we save. The Smart Device Generator has been automatically added. By default, it'll generate for Android and iOS, but Android will be the main platform. Note that below the Country node, the object Work with Devices Country is now displayed. Unlike the web example, in which Fiori list report country was only a declaration file, and the objects that effectively implement the pattern features were built separately, they're listed below. In this case, it's a GeneXus object that will contain sub-objects that can be invoked independently using the corresponding syntax. Let's also apply the pattern to the attraction transaction and to category. How can we test this quickly? One option is to use a device connected to the computer in which GeneXus is running. Another option is to use the emulators provided by the platforms. For simplicity purposes, we will use this option. To see all the prototyping options, we recommend viewing the course GeneXus for Smart Devices. Testing on an actual device will always be better because the emulators don't have all their features available. We're missing a menu. In the web environment, we had the Launchpad to invoke the list we're interested in. This menu is not automatically created by GeneXus. We need to create it ourselves. File, New, Object, filter by the objects for smart devices, and select the dashboard, which is an object to implement menus. We call it Travel Agency. This will be the main object of the application for smart devices. It'll be the object compiled by GeneXus for Android and/or iOS, and that the end user will install on his or her device once the development work has been completed. Let's enter the items we want to include in the menu. The first one will correspond to the action of invoking the list of countries. A window is opened to select the object we want to invoke when the user selects this menu item. We filter by object type Work with for smart devices. We select Work with Devices Country. And we now see this action, which by default receives the same name as the object invoked. This action, we double-click, will be associated with an event that programs the invocation. There, the list of the Work with Devices Country object is being invoked, not the detail. Let's open the action's properties and change the item description, which will be displayed in the menu at runtime. We will also choose an image for this option, bearing in mind that smart device apps tend to be much more iconographic than web apps due to the reduced screen size. We must import the image into the knowledge base from an external file. We select it here. Now, let's add an item to invoke the attractions list. Likewise, we change its properties. And then save. The object is set as main. Before running it, we replace the Android property base style with this one, so that the screen background is white with a dark action bar. To run it, we only right-click on its tab and select Run. If you have an emulator such as GeneMotion open, the compiled file will be automatically installed there and will be run. Otherwise, the default emulator of Android's SDK will be opened and the same will happen. We suggest using this option to avoid installing new software. In this case, we had GeneMotion open. So here we see the dashboard running with the two items defined with their images and descriptions. Tapping on countries displays the list of countries, which shows each country name in a grid. As it was implemented, if we tap on a country, we see the detail with two tabs. The general information in a tab, which is implemented here, and the country's attractions in the other tab. We see the attraction's photo and name as implemented here. Note that from the General tab, we can change or delete the country's information. We change the name, and we confirm. The object that updated the database was one of the REST services mentioned at the beginning. If we run the web application again and refresh the page, here it is. Likewise, if from here we change the name of France again and return to the Android device, we see it has been updated. The country's update and delete buttons are displayed here in the Work With in the application bar area. But while in the web pattern, the transaction was invoked when trying to update or delete. For example, here it's invoked in update mode. And what we're viewing is the transaction form. In native mobile applications, the same detail is opened, but with another screen, the edit screen. It looks exactly the same when initialized, except for the save and cancel buttons in the application bar. When the user clicks on the Save button, the device app will invoke, sending the data from this screen, the REST service in the web server containing the transaction logic, and therefore will update the information on the database. All of this is done in a transparent manner for the developer, who will not have to worry about these low-level details. Just like for the web pattern, if we return to the list, we see that it's possible to add a new country. Here, the same screen is invoked for the detail and for the update. We add Mexico. This is what the pattern generates by default. It can be customized though. If we open the attractions list, the attraction's image and name are displayed in the grid. We may also want to add the attraction's category. To do so, we open the toolbox, drag the attribute variable control, and select the category name attribute. We change the tag. We could delete it with label position none. We select Run over the main object. Note that by default, we're offered the option to make searches by attraction name. This is configured in the grid's properties here. We could add country name, for example, to allow making searches by country name as well. So if we search FR, France's attractions are displayed. We also have advanced filters by the attributes country ID and category ID, which are the foreign keys of the attraction transaction. Let's change the description to country and category respectively, and run the main menu once again. We open the attractions list and see that this option is available in the application bar. It offers the two advanced filters we've just seen. If we want to filter the attractions by country, for example, it opens the Work With Countries component for us to select one. Next, we click on Search. And the same will happen with the category filter. We can add filters or delete them. If we look at the list, it's ordered by attraction name. This is specified in the properties of the grid's data group. We may want to allow the user to order by country. Choosing the same option used for filtering, we can order by country. We see the Great Wall of China and the 2 attractions entered for France. We may want this option to show the information grouped by country, and for each country ordered by attraction name. To do so, we change this order. Adding the attraction name attribute, and indicating that the data will be cut by country name. Let's see this at runtime. This was just a small example of what we can do. Just like for a web application, there are more objects available to cover other features, such as panels for smart devices.